This is a little Arduino project, what we're calling a solar regulator, and it's for a solar powered plane where you have to limit the power being drawn by the motor so as not to collapse the voltage too much. So typically you get so many volts coming from the solar cells, might be 10 volts depending on how many cells you've got, and you want to draw enough current to pull that voltage down to maybe 80–85% of the open circuit voltage, but no less than that, and that gives you maximum power transfer and also stops you taking so much current that your receiver stops working and so on. So we've got a setup here, we've got a power supply up there set to about 6 volts but with a current limit on anyway, and then we've got lots of long thin cables driving it all, and eventually going to this motor and speed controller. I've got a transmitter here that we can send a signal with. So the throttle output from the receiver goes into this board, and then the output from there drives the speed controller, and I've also put a wire lead in and this servo so that we can see what the output drive is. So to begin with, I want to disconnect the power going to the motor and just work the throttle. If I put the transmitter in the shot as well, so you'll see as I work the throttle, the servo goes up and down, and it's going all the way up to 100% as you'd expect. Now if we reconnect the power to the motor like that, now we can try the same again, and you'll see this time to begin with the motor revs up as you'd expect, but there comes a point where even as I increase the throttle higher and higher, the signal driving the motor has topped out at about, what's that, 65%, something like that. So I can use anything up to 65% on the stick. If I go above that, the Arduino is limiting it. Now how does it do that? Here, I'll just show you this first. This is the I didn't say, I've also got on the Arduino, I've got, just to monitor it, I've got a serial interface, and this is the output from the program. So you can see the first figure, 5.03 volts, we'll come to that in a moment. The 5.99 volts is the measured voltage going into the Arduino, and as it's set at the moment it doesn't want the voltage to drop below that. And then the other two columns of figures are the first one is the input from the radio in microseconds. This particular speed controller is set so that it needs about 1100 before it starts, so I've got the throttle low set to that, but normally that would be maybe 1000. And then the other figure, which is currently showing 1674, that's the maximum that it's prepared to go up to at the moment. So you'll see as I advance the throttle, you see the voltage collapsing from about 6 volts there, 5.99. As we draw more current, we approach this threshold, which is what the first figure is. And when we get down to round about that 5.03 that's set, the sketch prevents the output to the motor going any higher than that. Now the way you set that, in this case 5.03 volts, is with this little pot on the, oh, if we can get this to focus, you can see there's a little trim pot there. So at the field, that's wound that down a little bit, sorry, up a bit. You see, as I turn the trim pot, you'll see that target voltage. I can go up to 8 point something volts and down as low as 3.3 volts. If we set it back to I don't know, 4 volts, 4.5, and see what happens then. Now it's letting us apply more throttle because we're getting up to, what is it, 100% there before the voltage starts to collapse as low as the 4.5 volts we'd set. Now if I leave that throttle going 100% but alter the current limit down on the power supply, again that will throttle back the motor as required to keep it running. You see we're down now to 50%. So that's like the sun going in behind a cloud, simulating that. If I wind the current limit up, I'm not touching the throttle, as more power becomes available, so the device will ramp us up to 100% eventually. So there we are. I will put a few still photos and maybe a circuit diagram of this device and the sketch, so that you can make one yourself if you're interested. Thanks for watching.